Roger Schlafly. I wrote this book because I wanted to understand better why Einstein is such a great genius. He's famous primarily for the invention of something called special relativity theory, and for that he's considered one of the greatest geniuses who ever lived. Special relativity consists primarily of the ideas that space and time are combined into one four-dimensional space-time, and that the motion in that space-time causes distortions to space and time by formulas known as the Lorentz transformations. And for that, Einstein is the great genius. However, I was never really sure just exactly what he did, because after all, Einstein did not get a Nobel Prize for relativity, and the Lorentz transformations are known as Lorentz transformations. They're not known as Einstein transformations. And the space-time is known as Minkowski space. It's not known as Einstein space. So I went back and I looked at the actual papers of what Einstein wrote and why he's credited. And I found that primarily he's credited for a paper he wrote on relativity in 1905. And supposedly that paper he abolished the ether and created special relativity theory. However, I found that's just most of what is told about Einstein this way is just not true at all. That the essence of the theory was done by other people. All of the essential parts, and I document this in the book, were done by others. In particular, the Lorentz transformations were done by Lorentz and others many years before Einstein. And the real heart of the theory is the idea that space and time could be combined into one four-dimensional geometry. And that geometry is characterized by a notion of a distance and a notion of the symmetries of that geometry. And that's not present in Einstein's 1905 paper at all. And furthermore, the really important part of that space-time geometry is that it applies to the equations of electricity and magnetism and light. And that is that the symmetries of the geometry are also the symmetries of the equations for electricity and magnetism and light by a mathematical process called covariance. And again, Einstein did not do that, did not understand that. Even after it was published by others, he didn't seem to understand it until several years later. And so my book explains all this. But the story of Einstein is actually only about half the book. I then look at the bigger picture in that relativity was discovered because people were trying to understand experiments about the motion of the Earth. There were experiments that were designed to detect the motion of the Earth, and they did not detect any motion, and it was very puzzling. And that's part of what relativity solved. And I look back at the history of this. The motion of the Earth is something that puzzled people for hundreds and even thousands of years. The ancient Greeks understood that maybe the Earth moves and maybe it doesn't. You could do astronomy and understand astronomy in terms of Earth motion or without Earth motion. They had arguments for and against the motion of the Earth, and that was a subject that was debated for many years. And I explain all that, and it's a fascinating story. And I also look at even the larger picture in terms of the progress of science. Science is usually described in terms of the revolutionary advances of people who worked with their lone ideas of thinking about how the world should work. People like Copernicus and Einstein and Galileo. And I show that this picture that's popularly